It's hard to find good news these days, so when scientists discover anything that could mean there's another place where life might exist in the universe, it's worth celebrating. And that's why I was pretty excited to hear about Titan's ice volcanoes. Some evidence suggests that our largest moon has cryovolcanoes that could replenish the methane in its atmosphere. It sounds pretty crazy, but let me explain. The discovery comes from observations of what appears to be a very young impact crater on Titan. We don't know exactly how old the crater is because we haven't been observing it for very long, but it seems like it's nowhere near as old as the rest of the surface. That suggests that something fairly recent happened there, something explosive. The researchers say the best explanation they have for this relatively young crater is that it was caused by an ice volcano erupting. Now, this isn't the first time ice volcanoes have been suggested on Titan. Back in 2019, a different group of researchers proposed that several cryovolcanoes were hiding in plain sight, specifically in this region of Titan called the Sandbox. They made their case based on the morphology of the land, in other words, the shape of it. These potential ice volcanoes are about 400 miles across, which is larger than the state of Texas, and they all seem to follow the same kind of pattern. There's a central peak ringed by steep cliffs that get lower and lower as you move outward. Kind of looks like a gigantic pile of ice was plopped down there and then eroded over time. But without any more evidence, nobody took them too seriously. It was just a cool idea, but still a hypothesis. But if this new crater really is evidence of a cryovolcanic eruption, then it means Titan could be geologically active today. And if it's still volcanically active, there's a chance it could be habitable. Let's talk about that second part first, because that's the exciting part. Scientists think life on Earth may have started in volcanic vents on the seafloor. And we know for a fact that vents like these still support ecosystems today. It's possible that life on Titan could be supported by similar vents, although I am sure the creatures that live near these vents would look very different from the tube worms we have here on Earth. But before we get carried away with that, let's go back to the beginning and explain what we actually know about Titan's volcanoes. They're called cryovolcanoes because instead of lava, they erupt some kind of ice mixture. But that's about the only thing we can say with certainty. Cryovolcanoes can erupt a bunch of different things depending on what's inside of them. For example, on Jupiter's moon Europa, they erupt water ice. Meanwhile, on Saturn's moon Enceladus, they erupt a combination of water ice and ammonia ice. On Titan, we're pretty sure cryovolcanoes would erupt some combination of water ice, ammonia ice, and methane ice. Methane is one of the key ingredients for life as we know it. On Earth, it's unlikely that life could evolve unless there was liquid water around. But it turns out Titan already has oceans of hydrocarbons. And what I mean by that is they have pools of liquid methane and ethane. These liquids are so corrosive, though, that nothing we currently have could explore them. NASA's Cassini orbiter tried once, and it ended up breaking the probe. Now, the problem with ice volcanoes on Titan is that we've never seen one erupt. The evidence for them is circumstantial at best. Take the sandbox structures, for example. While they do look a lot like piles of ice that have been eroded over time, they could also just be piles of material that were deposited by ancient rivers or lakes. Or maybe they're not piles of ice at all, but piles of solid organic material, stuff we would call rock. Either way, none of these are particularly exciting in terms of the potential for life. Meanwhile, the newly identified crater looks a lot more promising, but that's mainly because it looks so much like impact craters we see on Earth, the kind caused by asteroids slamming into the surface. Sure, it could be evidence of a volcanic eruption, but it could also be evidence of an impact. Maybe something hit Titan recently and blew a hole in the surface. Researchers did try to distinguish between these two possibilities and concluded that it most likely is a volcanic eruption, mostly because they didn't detect any ejector ray. An ejecta ray is a pattern we see after most impacts on solid objects in the solar system. You have the main crater in the middle and then a bunch of smaller craters around it formed by rocks and debris ejected from the main impact, but that's not what we see at this site. Instead, the lack of an ejecta ray tells us that whatever happened at this site, it didn't blow a lot of material far away from the actual explosion. And while that does sound a lot like a cryovolcanic eruption, it could also be explained by a different kind of explosion, one that doesn't involve ice at all. It's called a transient impact explosion. Instead of an asteroid hitting the surface and leaving a crater, a small asteroid just blows up in midair and then sprays rocks and ice over the surface. This wouldn't leave behind a classic ejecta ray, but it could leave behind a crater if enough material is blown onto the surface. So, as you can tell, there's a lot of uncertainty here. But one thing's for sure, both of these potential explanations point to a very young object. Whether it's an impact or a volcano, this event happened recently on the scale of planetary geology. And that's super exciting because it means Titan could still be geologically active today. Europa and Enceladus are also volcanically active, but their eruptions seem to have stopped a long time ago. Titan, on the other hand, might still have cryovolcanoes rumbling beneath its icy surface. The trouble is we won't know for sure until we actually see one erupt. We know there are cryovolcanoes somewhere on Titan. The question is, are they still active? What makes the discovery even cooler is that these cryovolcanoes could be replenishing the methane in Titan's atmosphere. As you probably already know, Titan's atmosphere is full of methane. There's so much methane in the atmosphere, in fact, that it rains and snows and creates rivers and lakes. But the real head-scratcher is that methane shouldn't be able to exist in such a tenuous atmosphere. Normally, planetary atmospheres lose their volatile gases over time. Gravity pulls them down to the surface, and then they either dissolve in the liquid below or freeze and become part of the crust. But that hasn't happened to the methane on Titan. Its atmosphere is almost certainly losing methane, but there doesn't seem to be any solid methane in the crust, and very little methane in the liquid either. So, where is it all going? One possibility is that it's being replenished by cryovolcanoes. Think about it. Deep under the crust, it's hot enough that methane could exist in liquid or even gas form. It could dissolve in a subterranean ocean or just sit in pockets under the crust. Over time, pressure could build up until it's high enough to blow through the crust and release the gas into the atmosphere. That would explain why the crust doesn't seem to have any methane in it. It's always escaping into the atmosphere. And if it turns out that Titan's cryovolcanoes really are volcanoes and not just piles of ice, then that means that Titan is still geologically active today. And if it's still geologically active, there's a chance it could be habitable. It is pretty cool that the discovery of these cryovolcanoes could potentially change everything we know about the habitability of Titan. It's a great example of how planetary science works. Scientists make a discovery, then they run with it, questioning everything until it can be proven or disproven. There's still a lot that we don't know about Titan, but every piece of evidence brings us one step closer to figuring out whether or not it could support life. And who knows, maybe someday soon we'll find out that it does. If you like optimistic science and tech stories, follow for more. If you want to learn more about cryovolcanoes, check out this video. If you want to learn more about Titan, check out this one. Thanks for watching.